When we buy sulfuric acid, we get it in those 4-liter jars, which is just about a gallon. Like I broke that day, that size. As concentrated as you can get it, it's 96.4% active ingredient, sulfuric acid. And remember, we name our solutions for the solute, so sulfuric acid. And then here's your magic word, it's in water. So that means that little tiny bit is water. And it says on the label, the specific gravity is 1.84. And what they ultimately want, they don't lead you by the hand, giving you a hint, you got to switch from here to here. It's just going to say, and what's the molarity? Emily, did that give you time to find it? Read and listen to how this is different, because this is a skill that is necessary to develop for test day. So read for me.
A sample of commercial sulfuric acid is 96.4% H2SO4 by mass, and its specific gravity is 1.84. Calculate the molarity of the sulfuric acid solution.
Okay, it wasn't a whole lot different, but there were a few words in there. There was one thing, percent mass, I think I did not have up here, but we understand when you're given a percentage about a solution, it's always by mass. The only people that use it by volume are people making wine and beer, and we're not in that business here at public school. So, although actually they make alcohol over in the organic lab sometimes, but that's another story. We have to watch it very carefully because we're very carefully regulated when we're making alcohol or using alcohol. You've got to have a log of every bit you have, every bit you spill, and account for it. So it's kind of interesting. Okay, now let's get started with this. If specific gravity is 1.84, you know, that's what medical people use. And we don't like that. As scientists, we don't like that. Anytime you see a specific gravity, not to be confused with specific heat, I mean, they start out with the same word, we want to switch immediately into density. Because, Sean, what's that going to be for density? Remember how we convert that? Yeah, it's mass over volume, but I want to know the exact numerical value. That's going to be useful because we know that's going to be one of the big hints. So we will need that. What would be the numerical value of a density?
1.84.
Exactly, but what do you have to add to turn it into density? What about you? Yeah, tell me more though. Not just grams. Per what? Not liters, what? Think smaller. Milliliters. Good, good, good. Okay, so something to remember. And as we do this all through the semester, this is also getting you ready for the final to refresh, because the more times you hear this, the more it's going to implant. Okay, so we go out of specific gravity into density. All we have to do, slap on the units and you've got it. Okay, so essentially what we need here, specific gravity we don't want. So we're going to switch directly over to density. Then, it's asking you for molarity. We have never done one like this together. And what makes this different, and what makes it a little bit harder, is you are in one concentration unit, you are being asked for another concentration unit. And we've never done that. You had, last Tuesday, what we did probably 4 or 5 problems that were just plain old percentage. And we did have some densities tossed in to make it really tough at the end, a couple of them. And then we moved into straight old molarity, but you never switched from percent to molarity or molarity to percent. Okay, here's a hint that you have to do. You've got to assume an amount. Now, it doesn't have to be a volume. I'm going to make an executive decision and say, we're going to use volume. And here was a nice little hint too. Make the math easy on yourself. Why not choose 1 liter of solution? Now, would everybody buy this idea? Let's say you drink regular Coca-Cola. Okay, you can buy it in those little tiny cans. You can buy it in the bigger cans. You can buy it in a 2-liter container. If you drink like a tablespoon of that, you got the same amount of sugar you just ingested, whether it came out of a small can or a big can or a liter, because the concentration of the sugar, you know, so many tablespoons per whatever, is the same. So that's why we get by with, I can choose 1 liter, I can choose 10 liters. If you want to make it hard on yourself, choose some weird number like 665 milliliters. But whatever you choose, it's going to work. That's point number 1. Point number 2, I could choose a volume or I could choose a mass of solution. Now, if you choose a volume of a solution, our order of operations will be a little different. In fact, it'll be the opposite as if you choose a mass. So I'm just going to arbitrarily say, let's choose a liter. Okay, so that's the big flash of insight when you've got to change units. That you've got to assume an amount. Make it easy on yourself. Okay, now let's look at clues. When you see this, in fact, let me just put that up. Well, no, we can't see it because I got the computer on. I don't want to switch. It takes too long. Okay, look at the clues there. How many clues do you see? Pedro, how many clues do you see? Or what's a clue in that one? Density. Okay. Actually, we saw specific gravity, but we're going to just get conditioned to switch immediately. So density is a big clue. And so Kashan already gave us the formula for that. So we brought it down. Okay, what's another big clue, Marco?
Maybe you can get the formula.
Okay, we may need it, we may not need it, but you don't see that as a clue. In fact, we will need it later on.
The percentage.
Okay, we see percent, and when Emily read it, I think the word solution was in there a couple of times in the sentence. So it's a percent solution, and it even said in the book, by mass. So we know this is a big clue. Percent concentration. Since it's a percent, we know that 100 goes out here. Now, let's write down our equation. Sarah, can you tell me the equation here for percent? What goes in the top? Not numbers yet, just general case.
Grams of solute.
Grams of solute. Could you go up?
Grams of solution.
Over grams of total solution. Word of caution to you. Yesterday I was grading Lab 7 for my other class. Guess how many missed a percentage problem because they put grams of solvent down there. I suckered them into that. So you want to check through your problems at 41 through 45 or whatever. Okay, so total solution. There's 2 clues we see. So here's a clue, here's a clue. Are there any other clues? Andrew?
It's an H2O.
Okay, yeah, it's in the H2O. So what does that word in? What does that tell you about the water?
It's a solvent.
Yeah, that's a solvent. And it's, especially when you first start these problems, it's always good to label everything, which means, of course, H2SO4 is what?
Solute.
Solute. Okay, but are there any more clues, any other equations we're going to need? Nicole, in the back, do you see any other clues, equations we may need? Okay, look this way. Look this way.
So I know which one.
Oh, you, Nicole. I'm sorry. I see the. We have 2 Nicoles now, side by side. So row 3, Nicole.
The molecular formula.
Okay. Well, we've got the molecular formula, and Marco had said we'll probably need the formula later on. But are there any other clues as far as some equation we're going to need? Other Nicole, let me try you. The molarity, yes. There's another clue. Okay, so, let me come over here. We should write this down, just the basic equation here. So Meredith, what goes in the numerator for
Moles.
moles of what?
Moles of
Solution?
or solids.
Which you want, you said that with a question mark at the end of it. Solute. Because for both of these concentrations, it's part over the whole. Okay, here it's part the solute over the whole, which is the total solution. So down here on the bottom, Meredith, do you remember? liters of solution. And notice on both of those, no mention is made of solvent. Okay, now, what makes this problem hard is we got to decide what's the order. We've got 3 clues. And you don't memorize, you always do this first, you always do that first. You look for your clues, you label your solute and your solvent, and then you've got to decide, and this is where the brain strain comes in, what comes first. Okay, now I know a percentage. When you see this equation, or this equation, or this equation, there's 1, 2, 3 variables, 1, 2, 3 variables. In order to solve it, you've got to know 2 out of 3. Okay, if I glance at percentage first, I know percentage, that's about it. Okay, now, let's see here. It's a real fine thing. If that's what you're asked for as your final answer, I'm going to put my money on that's going to be dead last. And I'm not even going to consider that. Okay? So it's really a question, do I use this first or do I use this first? Because if they're asking for molarity, that must be last. Okay, now, I made this decision that I have a liter of solution. And here, assume a volume, and let me mark that better. Of solution. Yeah, Andrew?
Why did you assume volume?
Because I'm out of luck working this problem if I don't have something to work with. And since we know concentrations are the same, whether you have 1 liter or whether you have 10,000 liters, whenever you have to change from molarity to percent to molarity, you've got to assume an amount. Now, I assumed a volume, okay? And I'm going to assume 1 liter to make the math easy. Okay, so should I start with density first or with percent first? Density. Why, Marco? Defend your answer.
Because you already got volume.
Yeah, you got
and
the
you got
volume,
density.
and you got density, you know, 2 out of 3. Okay, now, for those of you that are creative, what if you'd said, I've got 1,000 grams of solution? Or, for that matter, 1 gram of solution, a mass. Would you start with density first? You could start with percentage first. So that's why when you make a choice, if you go with volume, if you assume a volume, you go with this first for the very reason that Marco said. If you start with a gram of solution, then you get to start with this one first. And this right here, let me emphasize, is always of solution. And I think I mentioned before, I'll get right to you in just a sec. I mentioned before, I think I used ocean water as the example. You know the density of ocean water? It's not of the water, the pure water, the solvent, or it's not of the salts that are dissolved in ocean water, it's of the solution. And they don't spell that out real clearly, but that's of solution. Now, what was your question, Nina?
So you're saying since you weren't given the volume, you're just assuming the volume?
You've got to. When you got a percent and you're changing it to molarity, red flag, assume a volume. Concentration change, assume a volume. Or a mass, for that matter, but...
And that'll give you your 2 out of 3 that way?
Yeah. Otherwise, you don't have 2 out of 3.
Okay.
Okay. And, let's see, 1.84 grams per mil. Okay, I do not know mass of this solution, but I know the volume. Now, it's 1 liter, but what should I use? Instead of 1, I should use, okay, milliliters, which will be what? 1,000. Okay? All of this is of solution. And so we're going to solve for mass. And I know this is getting pretty cluttered up here, but let's solve for mass. When you solve for n, are you going to be multiplying or dividing? Multiplying, obviously, because it's just this times this. And milliliters will cancel. That's going to leave us with mass. Russell, what'd you get for mass?
1840 grams.
1840 grams of, and I'm going to emphasize, solution. It's just 1,000 times this. Okay, everybody holding up okay? Well, once we have that, let me make some space here so it's not quite so cluttered. We just did step one, and step one is right there. Now, step two, we're banking on percentages. Step two, since we asked for molarity, that's more than likely the last step. So now we've got percent. Well, we know that, don't we? 96.4. We know it's times 100. We've got our equation. Now what do I have here? Do I know the numerator or do I know the denominator? Denominator. I know that I've got 1840 grams of solution and I can solve for grams of solute. Okay, now, when we looked at percentage problems before, I said if you'll divide both sides through by 100, the math will suddenly become easier because you can do a cross multiplication and solve for that x. And when you do that, of course, that's going to be grams of solute. Emily, do you have a number for me?
1774.
Okay, and if I wanted to go ahead and round to the proper number of sig figs at that point, you would say what? 1770 grams of solute. Now, I don't care if you round at this point or you wait till the tail end, because what counts is the tail end for sigs. And of course, if you round at each step, you're going to get a slightly different answer than if you keep it rolling in your calculator. Okay, so this was step 2, right there. Okay, and this is a solute. And so now we can do the molarity. Okay, but we have to go back, work from chapter 2, assuming that we're working with a formula, a compound. You have grams and you've got to move to moles, which we have to do here for molarity. What is it I do with the formula weight? Allison? Divide. Okay, anybody have a formula weight for that? I think Marco said we were going to need it in this. And 98.1. Okay, so maybe off separate here. 1770 grams, so you can use 1774, I don't care. And we're going to divide it by 98.1 grams per mole. And that's going to give us moles. And then we're in business over here. Nikki, do you have that? Third row, Nikki. Nicole.
Yeah, it's 18.1.
18.1
I
moles.
used the 1774, just so.
Okay, 18.1. Somebody that used 1770, did you get anything different? 1808. Okay. Either way, because when you wrap it up, you're still going to get 18.1. What's my volume of my solution? 1 liter, because we chose it. Okay, way back up there, we chose it. And see why that is a nice decision? Because you don't have to pick up your calculator there. If you'd chosen 665 or something, welcome to using your calculator. It would still work, you'd still get the same answer. But this means the molarity of this solution is 18.1. What's another way to say that? If I don't want to use the whole word molarity, what else could I say? Molar. I can say it's an 18.1 molar solution and use it as an adjective, first 2 syllables. But it all means the same thing. Now, I've made a big, big mess on the board here. But let's go back and look. We see density in the problem. It was specific gravity, but that was just to trick us, so we know immediately, switch it over. So we have a density issue, we have a percentage issue, we have a molarity issue. And the brain strain is to decide what comes first. Okay, there was no brain strain really, molarity is going to come last, because that's what you're asked for. You know, in those problems where all we had to worry about was percent and density, like last time, and they ask you for a volume, I bet you density comes second. If they start you out with a volume, I bet you density starts first. is your first step. So here we took the density, because we had to choose an amount, okay, and so we got the volume, is 1884 grams. Okay, then we came down here and we did this as our step 2. We had the percentage, now we have grams of solution by working the density. So you got grams of solute. We switch grams of solute into moles of solute. Think of all the things this thing reviews. It reviews all your concentration units, plus it takes you back. You're going to have to do this. It also takes you back. You need to come up with a formula weight. Now, when you look at this later today, and I hope you do, give it a little time, let it digest, come back to it. If you see a number like this and you go, where did that come from? Anytime in your notes, and there's a number, you just don't know where it came from, I'll put my money on it's a formula weight that somebody just provided for us. Okay, that's a great review problem. Okay, now.